Okay, 6.3a is on regular polygons, and it is on page 442 in the book, and so please follow along on page 442. So first of all, the definition of a regular polygon. A regular polygon is going to be both equiangular and equilateral. Alright, so what does that mean? Equiangular, it means that all the angles will be the same. All the angles will have the same measure. And equilateral, all the sides have the same measure. So now there's a few pictures here. This first one, right here, shows a hexagon, and it is equiangular. So these angles are all the same, but it's not equilateral. The sides are not all the same. This second one here looks like a rectangle, and it is. What a rectangle is going to be is it's equiangular. All the angles are the same, but it is not equilateral. The next one is a rhombus, and a rhombus is equilateral. Equilateral, all the sides are the same, but it is not equiangular. The third one is a square. A square is a regular polygon. It's a regular quadrilateral because all sides and all angles are the same. All sides the same measure, all angles the same measure. Now, we're going to do an investigation about the number of sides of a polygon and then the sum of the interior angles, each interior angle, each exterior angle, and the sum of the exterior angles. We already know the sum of the exterior angles of any polygon is 360. We know how to do the sum of the interior angles, which is n minus 2 times 180. So for a triangle, it is 180. For four-sided quadrilateral, it's 360. For five-sided, we're doing n minus 2 times 180, so 3 times 180, 540. For six-sided, it's going to be 4 times 180, or 720. For seven-sided, 5 times 180, 900. For an eight-sided, 6 times 180 is 1080. So for n, we know it's n times 2 times 180. Now each interior angle. So in a regular, we're talking here about regular polygons. So that means every angle is going to be the same. So if it's 100, you divide it by 3. 1080 divided by 8, which is 135. So the formula for each interior angle, you're going to take the n minus 2 times 180 and divide that by n, the number of sides. Now for each exterior angle, it's always, the sum is always 360, and so we're taking 360 and dividing by 3 and getting 120. Taking 360, dividing it by 4, 90. The other way we could figure out the exterior angles is that the interior and the exterior angles are supplements of each other. When you think about the picture of the triangle, here's the interior, here's the exterior. So these two numbers are going to always add up to 180. So this one is 72, this is 60. I'm going to do this fractional again. 51 3/7, 45. And so we know there are two ways we can do it. These two are supplements, or we know that the sum is always 360 and you're dividing it by the number of sides. So, the measure of each interior angle of a regular polygon with n sides can be found two ways. We can go n minus 2 times 180 and divide that by n. Or, since these two are supplements, and we know that the exterior angle is 360 divided by n, if they're supplements, then the interior, each interior, is 180 minus that 360 divided by n. The measure of each exterior angle is always going to be 360 divided by n. So in everything we're doing is a regular polygon. If the angles are all the same, each exterior is this, and each interior is this. These are the two formulas that we need. So I'm going to do the problems down below first, and then come up to these number 1 and 2, which are harder. So number 1, what's the sum of the measures of the exterior angles in a decagon? So it has the sum of the measures. It really doesn't matter what it is. If they're asking me for the sum of the exterior angles, it's always going to be 360. Number 2, what's the measure of each exterior angle of a regular decagon? So each exterior, and a dodecagon is 12 sides. So each exterior is 360 divided by n. So we're going 360 divided by the number of sides. So each exterior would be 30 for the 12-sided figure. How many sides does a regular polygon have if each exterior is 24? So each exterior is 24. I set that equal to the formula for finding each exterior, which is 360 over n. I'm going to cross multiply and get 24n equals 360. And n is going to be 15, so 15 sides. That would have been a 15-sided figure. Now I'll come up and do these harder ones. So I want to find C and D. And I'm going to first look at this figure that has 1, 2, 3, 4, 5, 6, 7 sides. So it's a regular 7-sided figure. So I want to find out what each one of those angles are. I'm going to do 7 minus 2 times 180 divided by those 7 sides. That's 5 times 180 divided by 7 comes out to 128 and 4/7. So each one of these is 128 and 4/7. Now, in this middle here, these three angles are going to add up to 360. And I'm going to name this one E. And that would also be E. So 2E plus 128 and 4/7 would equal 360. 2E would equal 360 minus 128 and 4/7 is 231 and 3/7. And I divide both sides by 2 and get that E is 115 and 5/7. So I'm now going to find C, and I know that C is going to be 180 minus this angle, which was 128 and 4/7. So that equals 51 and 3/7. That's my C. I've got C, I've got E, I don't have D, and I know that last one is 90. So I can add those up. I've got 51 and 3/7 plus 115 and 5/7 plus 90 plus D is going to be equal to 360. Adding these three up, I believe I get 167 and 167 is just these two. So 167 and 1/7 plus 90 plus D equals 360. That's 257 and 1/7 plus D equals 360. My D is coming out to be 102 and 6/7. Double check yours, make sure you get the same thing. Let me know if I've made a mistake. Okay, number 2. I'm starting with this 8-sided figure. So each, probably going to need more space here. So each side of this 8-sided figure, each angle is going to be 8 minus 2 times 180 times 180 divided by 8. That's 6 times 180 divided by 8 comes out to 135. Each of these angles is 135. Then I've got a 5-sided figure, which is going to be 540 divided by 5, which comes out to 108. So each of these angles is 108. So from that I can find E. E is going to be 180 minus 108. So E is 72. I can find G because G is going to be 108 plus 135 plus G is going to be 360. So go ahead and figure out your G. And did you get 117? And then F is just going to be 180 minus 135. So F is F is 45? Yeah. And then we need H. So you go ahead and figure out H. You're going to have, I believe you now know 3 out of those 4 angles in that quadrilateral. Go ahead and figure out H, and then come back to this. And I believe I got H is 126. Okay, number 4. How many sides does a regular polygon have if each interior is 165? So I find the easiest way to do these is just to use the formula for each interior and set it equal to 165. So I'll show you both ways, but this is each interior is n minus 2 times 180 divided by n. I solve this by multiplying both sides by n. I get 165n equals n minus 2 times 180. I'm going to distribute the 180. So 165n equals 180n minus 360. And then I'm going to subtract the 180n from both sides. So I get negative 15n equals negative 360. Divide both sides by negative 15, and n equals 24. So meaning I would have 24 sides. The other way to do it is to say that each interior and each exterior are supplements. So 180 minus each exterior is 360 over n, and that altogether is going to equal 165. I find this way harder, but I'm going to subtract 180 from both sides, and actually I'm going to add 360. This is negative. I'm going to add 360 over n to both sides. So 180 equals 165 plus 360 over n. Then I'm going to subtract 165 and get 15 equals 360 over n. Multiply both sides by n, get 15n equals 360, and again n is going to equal 24. I actually just like this way better. I just set it equal to the formula for each interior angle. Number 5. How many sides does a regular polygon have if each interior measures 150? So I'm going to do the same thing I did up here. 150 equals n minus 2 times 180 over n. Multiply both sides by n. 150n equals 180 times n minus 2. Distribute the 180. Okay, so we're going to use this polygon inscribed in this circle. First, draw the center of the circle. So make a dot at what looks like the center and label it C. Draw a radius to one of the vertices. So I'm drawing this red line to one of the vertices. Then draw a perpendicular segment from the center to the side of the polygon. This is my perpendicular segment. When you describe a regular polygon in a circle, a few things are true. First, you have a radius of the polygon, same as the radius of the circle, but it's the length from the vertex to the center. And just like any radius, all the radii are going to be the same length. Now, you also have an apothem. So this is my apothem. So the apothem is the perpendicular segment from the center to a side of the polygon. The perpendicular segment from the center to a side of the polygon. And we call it A. Now there's a way to figure out the area of any of these regular polygons. Got to be a regular polygon. And A is going to be equal to 1/2 little a times P. So in this formula, A is the apothem, and P is going to be the perimeter of the polygon. So in the first example, you're not going to get any that are this easy again, but they're giving you get a regular pentagon, they're giving you the perimeter, they're giving you the apothem. So it's 1/2 A times P, which would be 1/2 6.9 times 50. It comes out to 17.25 inches squared. So in this case, they've given you everything you need. That's not usually going to be the case. I want to also go back and give a definition for this center. It is the center of the circle, but it's also the center of the polygon. And it has a definition. When it is the center of the polygon, the center is the point of intersection of the perpendicular bisectors of the sides. Let me say that again so you can write it. And it is in your book on page 442. The center of the regular polygon is the intersection of the perpendicular bisectors of the sides. So another thing that you're going to find when you have that center, if we put in all these radii, then we end up with 5 isosceles triangles. All the radius have the same measurement, and all of these sides have the same measurement. And if it is a 5-sided figure and you've got these 5 triangles in here, then each one of them would be 360 divided by 5. So each one would have this measurement of 72, each of these angles. That's going to become important. So on this next page, find the perimeter and area of a regular triangle with apothem 10. So I'm going to draw this regular triangle, and here's the apothem, and the apothem is 9. And I'm going to draw in the radii of this triangle. I'm going to put all 3 of them in. The reason I want 3 is because now we know that each one of these would be 360 divided by 3, or 120 degrees. And what's even more important is that we're going to need this angle in here is 120 divided by 2. So this little triangle inside here is going to be real important. I'm going to redraw it. That's the apothem, and it's 9. This is 60 degrees, which means that would have to be 30, and this being 90. So I need to figure out the perimeter of this triangle. So I need to figure out each one of these sides. I don't really want to call it S. So I've got, in here, I've got 30, 60, 90 right triangles, with this being 9. The side opposite 30 is 9. So remembering our 30, 60, 90 right triangle model, the side opposite 30 is x, and the side opposite 60 is x radical 3. So our side that's opposite 30 is 9, which would make this be 9 radical 3. So each one of these is 9 radical 3, and each side would be 18 radical 3. So the perimeter is going to be 18 radical 3 times 3. So the perimeter is 54 radical 3. And then the area is 1/2 of 9, because I'm now doing 1/2 the apothem times the perimeter. 1/2 9 times 54 radical 3. So it's going to be 9 times 54 and then divide by 2. I'm just going to check mine. 54 divided by 2. So I get 243 radical 3. I'm going to leave my answer with a radical in it, inches squared. And that would be the area of that regular triangle. Next example, find the length of the apothem and the radius of a regular quadrilateral with, this is supposed to say area, 100. So if the area of this regular quadrilateral, which means a square, is 100, then each side is 10. And then the apothem would be 5. Now I'm going to find the radius. So this has got to be, we're inside of a square, and each one of these angles is 90. Each of these is 90. So this one in here is a 45, 45. Let me redraw. This, what I'm drawing is this angle has got to be a 45, 45 right triangle with this side 5. So this side is also 5. And if you remember the 45, 45, it's x, x, and x radical 2. So therefore the radius is 5 radical 2. And this is being measured in meters. The radius is going to be 5 radical 2 meters. The next one. Find the area of a regular hexagon with perimeter of 72. So in the hexagon, we're now going to divide this up into 6 triangles, 6 isosceles triangles. So each angle here is 360 divided by 6, or 60 degrees. So therefore, when I bring down the apothem, each of these gets divided into 30. So that's my 30 degrees, that's my 60 degrees. So it's a perimeter of 72, and there's 6 sides. So each side here is 12. So down here, each of these is 3. So my side opposite 30 is 3. So my side opposite 60, I don't know if I did this right. I'm going to stop and fix it. Okay, each side was 12, so each of these is 6. So my side opposite 30 is 6, so my apothem is going to be 6 radical 3, because that one is the side opposite 60. So my area is 1/2 the apothem, times 72, the perimeter. This, double check my work, please. This comes out to 216 radical 3 inches squared. Do check that and let me know if you get it different. Next example. Find the length of the apothem, the radius, and the area of an equilateral triangle with side length 6. So here's my center of this triangle, and here are my 3 isosceles triangles. So each angle here is 360 divided by 3, or 120. Therefore, when I bring down my apothem, each of these Okay, so dividing both sides by radical 3, then rationalizing, I get that x is 3 radical 3 over 3, so x equals radical 3. So that is my side opposite 30, which is my apothem. So my area equals 1/2 the apothem times the perimeter. Each side is 6, so the perimeter is 18. I get 18 divided by 2, 9 radical 3 units squared is the area.